Hello, my AP Calculus AB kids. We are looking today at section 5.3 that's talking about increasing and decreasing intervals and how do you know where they happen by either looking at the graph or given an equation. We're going to talk about critical points, which were brought up in the last section, and so that's what we're going to start with. So find the critical points of the graph of f. If you remember from last section, critical points happen when the first derivative equals 0 or the first derivative is undefined. Remember slope dude undefined. Right, there it is. Doesn't exist. Undefined. So when the slope of the function is positive, the function is increasing. In other words, the first derivative, slope, first derivative. When the slope of the function is negative, first derivative is negative, then the function is decreasing. And really, that's the hot topic of the day. So it's relatively simple. This time they give me the graph of f of x, and I can see that all along here I would have positive slopes of my tangent line, right? Then I get up to the peak here. When I get to that peak, what's the slope now? And hopefully you remember that that would be a horizontal slope. If it's a horizontal slope, that's when the first derivative equals 0. The slope equals 0. Slope and first derivative are the same thing. Then I come skating along here, and this is now a negative slope. Negative slope. Can I write it this way? Till I get to here, and then I have another time when the derivative equals 0. Slope is 0. Then I come skating up to this place. Now this is an interesting location, right? Because if I think about what the derivative is there, you should be thinking that maybe there's a problem, and there is a problem, and the problem is you've got a pointy place. And so this one has a slope that doesn't exist. Do you want to put DNE? Does not exist. Undefined, same thing. And then I skate along here again, and this guy has a negative slope again. In other words, the slopes of the tangent lines, any tangent line I make over here would have a positive slope. Any tangent line I make over here would have a negative slope. Oh, I forgot this guy. This guy's a little positive slope in here. Positive slope. And then I get up here to the doesn't exist, and then I do negative slope again. My tangent lines would all be negative slope. So what you do is you create a sign chart out of this. And I know the curriculum folks, they like making this big old sign chart. I'm going to show you a shorter way in a couple minutes of the way that I do a sign chart without all this big stuff going on. But let's take it in pieces. My x values, when my x values go from negative infinity until I get to this peak, well, that's an x value of negative 3. Or no, I'm sorry, positive 3. This starts at 0. So this is 0, 1, 2, 3. So that's to 3. So on the interval from negative infinity to 3, I have a slope that is positive. Then I get to the peak at 3 itself, and at 3 itself it has a slope of 0. Sign of this thing, so maybe we can put over here in parentheses, this is the slope they're talking about. Ooh, can you see me? There you go. All right, then I get to the next section from 3 until I get to 5. So the next thing I've got is the interval from 3 to 5. All of those guys have a negative slope. Then I get to 5. At 5, I've got a slope of 0. Then I go from 5 to 6 with a positive slope. I get to 6 itself, which doesn't exist. And then I go from 6 to infinity, and that all has a negative slope. So you just found the intervals where the derivative is positive or negative, and then shows where the graph is increasing or decreasing, because again, any positive slope is going to be an increasing part of the graph, and any negative slope is going to be a decreasing part of the graph. And then you've got the zeros there. So this guy's going to be increasing. And then you've got this part is decreasing. Big thing is Positive slope increases, negative slope decreases. Find the intervals, number 1, on which this function, now they give you an equation, is increasing and decreasing. Justify your answers. So the first thing you want to do is find the critical points. To find the critical points, remember that's where the slope is 0 or undefined. So if I look at this, I'm going to take the first derivative. F prime of x gives me negative 2x minus 4. I set it equal to 0. Bring the 4 over. And I get an x that's negative 2. Find the critical point. We did. In between the x values, the derivative must be positive or negative. So in other words, to the right of negative 2 and to the left of negative 2, we should have values that are positive or negative. So here you set up the chart. They started you out with it. We know that we've got negative 2 as our critical point. I don't know what it's doing to the left and I don't know what it's doing to the right, but I can certainly figure that out. And you can't see me anymore, so let me move myself up. It's stuck on my desk. All right, there we go. All right, let me move it too so you can see the whole thing. So to the left of negative 2 would be from negative infinity to negative 2. To the right would be from negative 2 to infinity. We know at negative 2 itself, it's got a slope that's 0. And so what do? You've got to test numbers to figure out, so we can use a chart to help keep track of the information, write the critical point in the of the first derivative. Okay, here you go. We set it up just right. So what you want to do is you want to take your first derivative, f prime of x. We know what that is. It's negative 2x minus 4. And I want to test points to the left and to the right. And you can pick anything you want. So say I go left, f prime of, if I went negative 2 and I go left of negative 2, I don't know, I can go negative 3, right? That would be left. Plug a negative 3 in. Negative 2 times negative 3. Minus 4 is 6 minus 4, or 2. That's a positive. So all you have to do is say that that's a positive. You can use words, you can use symbols. Then I'm going to go to the right of negative 2, which maybe 0 might be a nice one, right? Again, you can pick whatever you want. And if I put that in there, I get 0 minus 4, or negative 4, and so this would be a negative. All right, so the question was find the intervals on which the function is increasing and decreasing, and justify your answer. So now you're ready to give them actually the answer that they're looking for. And so our answer is going to be that it is, first of all, plus, positive. So that means it's going to be increasing from negative infinity to negative 2, because f prime of x, the derivative, is positive. You could use those words, you can use the math symbols, and it's going to be decreasing from negative 2 to infinity because the first derivative is negative. And that's it. That's all you need to do. All right, we're going to try another example on the next page. Let's see. Number 2. Find the intervals for which this function is increasing and decreasing and justify why. All right, so I didn't show you how to do it with my shorter version rather than the big old chart. I'll show you this time around. So same idea. I got to take the first derivative. It's all based on off of what's the first derivative doing. So if I take the derivative 1/3 x cubed, it's x squared minus 2x minus 15. I set it equal to 0. To find my critical points so I know what I'm putting on my chart. All right, hopefully it factors. Most times it should. I get minus 5, I get positive 3. Gives me x equals 5 and x equals negative 3. Now instead of doing this whole chart here of dividing it up, here's what I tend to do. I just make a number line. And on my number line, I put a negative 3 and a positive 5. And then I can see what I need to test to the left and to the right. So what I do is I figure out, all right, well, let me take a point over here to the left of negative 3. So if I do, say that I do f of negative 4, that's a 4. I put it into my first derivative. So I have negative 4 squared is 16. I have negative 2 times negative 4, that's positive 8. So I have 16 plus 8, that's 24. And all I care about is it positive or negative? I don't care what the actual outcome is. So I'm at 24 minus 15, and I know that's going to be positive. So on my chart over here, I put positive. And then I pick a number between negative 3 and 5, like 0. So I want to know what's f prime of 0. Put 0 in here. 0, 0, negative 15, it's negative. Take something to the right of 5, like 6, f prime of 6. 6 squared is 36, minus 12 is 24, and 24 minus 15 gives me back to positive again. And there you go. So instead of setting up such a chart like they did, which is not a wrong thing to do, it's just, to me, seems like more work than you need to do. So then the question is, where are you increasing, where are you decreasing? You can tell right from your chart here that it is increasing anywhere you've got a positive derivative. So it is increasing from negative infinity to negative 3 and from 5 to infinity, because they want justifications, your first derivative is positive. And then it's decreasing where your sign chart, these are called sign charts, by the way, it's decreasing from negative 3 to 5. Because your first derivative is less than 0, negative. It's negative. Okay, number 3. So those are pretty simple, whether they give you a graph or whether they give you an equation. So number 3 says, okay, well, here's a graph, and this is the graph. You got to watch what graph they're giving you. They're giving you the graph of f prime of x. See if I have any highlighters here. It's really important for you to check and see what exactly they're giving you. Sometimes they give you the regular function, sometimes they give you the derivative. In this case, think about this. The derivative is positive when I'm looking at a derivative graph when it's above the x-axis, and it's negative when it's below the x-axis, because I'm looking at the derivative graph. All right, so let's see. Determine the intervals where this guy's increasing or decreasing based off the graph of the derivative. So the first thing that I have are y values that are above the x-axis. That's an increasing part. Negative infinity 2, the x value of negative 3. And I'm just reading this graph from left to right. And then I'm going to say, all right, here it crosses over. So from negative 3, negative, 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 what values for y until I get to 1. So it's decreasing from negative 3 to negative 1. And then it goes above the x-axis from 1 to 3, so now I'm back to increasing from 1 to 3. And then it goes below the x-axis for the rest of the time, so it's from 3 to infinity back to decreasing. Let's see if we've answered their question. Determine the intervals where f is increasing and decreasing based off the graph of f prime of x. And there you go. Now, they might want justifications. If they do, you can use your same justifications you did up here. It's increasing because the derivative is greater than 0, and it's decreasing because the derivative is less than 0. All right, last piece. If you want to know if something is increasing or decreasing, you look at the signs of its rate of change. In other words, you know rate of change as being the first derivative. You check out the signs. Positives increasing, negatives decreasing. So the sign of the rate of change can tell you if the dependent variable or your y value, by the way, is increasing or decreasing, interpret the following. My students per year is greater than 0. So would that be an increasing situation or a decreasing situation? Greater than 0 is increasing because it's positive. So you would say the number of students, I can't see my left part here, the number of students is increasing. They're just asking you interpret the following. Are these increasing or decreasing situations? The next one is less than 0. That's going to be a decreasing situation. So the number of miles is decreasing. Next one is mastery checks per week are greater than 0, so the number of mastery checks is increasing. And the last one is less than, so this one is the rate of virus cases per month. See how this one's month squared? So this one we want to add that in. The number of, funny enough, this was made before the COVID stuff happened. The rate of virus cases per month is decreasing. Okay, there's a situation. Here's the last one. This one says the rate of change of fruit flies in Mr. Kelly's kitchen at time t days is modeled by this equation, flies per day. Show that the number of flies is decreasing at time t equals 3. How do you show that anything is decreasing? And your answer is you find the first derivative. And so that's what we want to do. We want to know what r prime of t is. Oh man, this guy's got to be a, there's a couple of different ways you can do it. This one would be a product rule, right? 2t cosine of t squared. But really you can just go to your calculator. And what you want to know, oh, sorry, wait a minute. You don't want to know r prime of t. They're giving you the rate of change already. So they already gave you that. Sweet. We don't have to find the derivative. So r of t is the rate of change. Watch your wording. They just almost caught me. R of t. So I want to know what r of 3 is. So all I have to do is plug a 3 in. 2 times 3 cosine of 3 squared. 6 cosine of 9. So I go to my handy dandy calculator and I say, all right, Mr. Calculator, what is this? And the answer comes out to be negative 5.4667. And see how this is a negative right here? You're getting a negative value out for your rate of change, for your derivative, because that just verifies that it actually is decreasing. Decreasing means this negative that's there. So therefore, 3 dots, the number of flies is decreasing because r of 3, when I plug a 3 in, I get a value that's less than 0, a negative value out. All right, so that does all of the examples for this section. I want to look at a couple of practice problems. I'm just going to pick a few. I don't think the ones from the graph are all that hard, so let's go to, let me see the one that you might pick, probably number 6, because you see the trig functions and you get freaked out. If I look at this and I want, the question says, and you can't see the directions on the screen right now, but for each function, find the intervals where it's increasing and decreasing and justify your conclusions. Construct a sign chart to help you organize the information, but don't use a calculator. So we're supposed to not use a calculator on this. So we'll see how good we are. All right, so if I look at this, I am looking at, I want to take the derivative. I have to take the first derivative in order to figure any of this out. Increasing, decreasing, again, comes from first derivatives. So if I look at this a little differently, g of t is 12, I'm going to distribute it, plus 12 cosine of t. And that's a little easier for me to take a derivative of, which means that g prime of t, derivative of 12 is 0, 12 cosine, derivative of cosine is negative sine, so it's going to be negative 12 sine of t. What am I supposed to do with that first derivative? I'm supposed to set it equal to 0 to figure out what goes on the sign chart. All right, so here I am. Divide by negative 12. Now I've got 0 is the sine of t. you need to remember your unit circle. I giggle because I know you're probably pulling out your charts. Where is the sign 0? Where is the y value 0 when I'm looking around the unit circle? And that would be at 0 itself, at, look at me over at my interval here, at pi. And see how there's parentheses? So I got to take it one more to 2 pi. At those 3 locations. So I'm going to construct a sign chart and put those values on there. First value is 0, second value is pi, third value is 2 pi. Now, interestingly enough, my domain only goes between 0 and 2 pi, so I don't care what's happening over here. I don't care what's happening over there. It doesn't go on to infinity like some of the other ones that we've seen. So all I need to know is what it's doing in between these 2 places, which means when I go to test values, take nice values, right? You're talking the unit circle. So I want to know what g prime, I would probably pick pi over 2 in there, right? That would be a nice value. And this would be g prime of 3 pi over 2. So again, I'm thinking unit circle in this case. At pi over 2, the coordinate is 0, 1. At 3 pi over 2, the coordinate is 0, negative 1. I want the derivative. So negative 12 sine of t. Again, I only care if it's positive or negative. I don't care about the actual value. Sine is the y. So negative 12 times 1 gives me a negative for this side. Negative 12 times negative 1 gives me a positive on this side. Question's asking where is it increasing and decreasing, and to justify. So it is decreasing first from 0 to pi because g prime of t is less than 0, and it is increasing from pi to 2 pi. Can you still see me? Barely. Pi to 2 pi because g prime of t is greater than 0. And there you go. So you can do it for trig functions. Let's take it to a word problem like, oh no, let's say number 11. Be careful of number 10 and number 12 because see how they have the rate of money? That's your rate. That's the derivative. Same thing happens in this second one here, this number 12. This is the rate. That's the derivative. So watch your wording, whether they're talking about the original function or they're talking about the derivative. 11's different because the number of hair follicles on Mr. Sullivan's scalp is measured by this function where t is measured in years. Is the amount of hair increasing or decreasing at t equals 7 years? So is this one that they gave us the derivative? And the answer is no. So what I need to do is figure out what h prime of 7 is, 7 years. And all I care about is it positive or is it negative? Now watch your directions too. They said calculators used and encouraged. So we're going to go to our calculator. We're going to take the derivative of this and plug in a 7. A lot of you like to make a graph of it. Remember if you go from the graph and then you F5 it on our 89 calculators, it'll let you plug in what the X value is you're concerned about and then tell you. But when you do that, however you want, you can do it in the home menu too. You get negative 0.4559. It's a negative value, therefore we know it's decreasing. Decreasing because h prime of 7 is less than 0. It's a negative value. All right. I want to do, looking at what we've got left here. Let's take a look at number 13 as our last one for the day. So number 13 says, I know you get all discombobulated with some of the verbiage of these things. So the table above gives values of the function f at selected values of x. If f is twice differentiable, in other words, the second derivative exists, it's continuous there. On the interval from 1 to 5, which of the following statements could be true? All right, well, I'm thinking about this. They're talking about the first derivative. And all of these values here are from the original function. So I have to think about how this thing is going to work. And all of this comes down to, let me figure out what the slope's doing. I want to know what f of b minus f of a is over b minus a, because that's what the first derivative is. So what I'm going to have to do is kind of play around with this thing and figure out if my slopes are positive or negative. A couple different ways you could do this. You could literally figure out the slope between each of these things, right? -1 minus 6 minus a -6 over 2 minus 1. Think about that. That would be positive, right? It would be positive 5. If I go 3 minus a -1, that is 4. 4 over 1 is also positive. If I take 6 and 3, I get 3 minus 1, so this is positive. And if I take 8 minus 6, that's 2 over 1, so that's going to be positive. So all of my slopes are positive. In other words, I can get rid of A and B. But my slopes are all, these are negative situations. So it's either this or it's this. So let's think about it for a minute. Now I got to figure out if it is decreasing or increasing, because I'm down to these two choices. So if I'm looking at it, now this is talking about what the slopes are doing. Is the slope decreasing or is the slope increasing? So I could also just plot some points, right? Can't I just plot them? They're x and y values. Rough plot here. If x is 1, y is -6. If x is 2, y is -1. If x is 3, y is 3. If x is 4, I get 6. And 5 gives me 8. So if I look at this, all of my slopes, which of the following could be true? Could be true. My f prime for my function, for f prime, I'm talking about what the slopes are doing. Are my slopes, it's kind of hard to tell from this, the slopes of the tangent lines, are the slopes of the tangent lines getting bigger or smaller? And I guess my picture doesn't do it much justice. But if I look at the slope here of this of the tangent line at this place, and then I look at the slope of this guy, if I look at these, my slopes are kind of, the tangent lines are getting smaller. So the slopes of those at those locations. So it actually is, although the function is increasing, the slopes are getting smaller. So the answer is C. And so there you go. That is section 5.3. So shoot me an email if you've got any questions, and otherwise I'll see you in class.